Don't say a word. Doc! I don't want to know your name. I don't want to know anything. Listen, Doc! Quiet! Doc, it's me, Marty. Don't tell me anything. Doc, you gotta help. Quiet. I'm gonna read your mind. Now let's see. You've come from a great distance. Yes. Don't tell me. You want me to subscribe to your YouTube channel? No. Not a word now. Quiet. You want me to make donations? You want me to make a donation to your Twitch channel? Doc, I'm a developer. I came here to learn about a device that you hacked. Now I need your help to upload my brain to the cloud. Do you know what this means? It means that this damn thing doesn't work at all. Doc, you gotta help me. You are the only one who knows how to upload my brain to the cloud. So, is there a relationship between cognitive function and video game performance? In other words, when I'm focused and attentive, do I play better? Or when I'm distracted, do I play worse? Is there any connection at all? Can I even test this? Now, I'm not really sure, but that's what I intend to find out. Now, like all good experiments, this project begins with a few questions. The first question is, can I read my own brain data? If so, is the data valid? Can I improve my performance in video games by being really super focused and concentrating? If I'm distracted, will I play poorly? Will a bad game be visible in my brain activity? Is there a direct, measurable relationship between superior gaming performance and high levels of attention? Or are there just too many factors at play? To answer those questions, I've set the following objectives. Now, obviously, the first goal is to capture my brain data at home in an accurate and cost-effective manner. Next, I think it's necessary to establish a baseline mental state, just some readings to see where my brain is at. Then, I'll need to capture my brain data while playing a video game. Now, to compare these things in an objective manner, I have to find a way to actually quantify my video game performance with data. Then, I'll have to establish and visualize a relationship between the cognitive measures and my video game performance. Now, of course, there are constraints and outside factors that come into play. Can those outside factors be excluded? Things like server and network latency, skill-based matchmaking, the opponent's skill level, and all kinds of other unknowns. Now, that part concerns me a little bit, but we'll see what happens. Since I'm taking the scientific approach to this, I guess it makes sense to associate this project with a hypothesis statement. Now, as far as that goes, I guess that could be stated as, the more focused I am, the better I will perform at an online multiplayer first-person shooter, Call of Duty Vanguard. Conversely, when I'm distracted, my performance will be negatively impacted. So, how am I going to upload my brain to the cloud? Well, let's imagine that this is my brain. Well, okay, maybe that's a little bit generous. There, that's better. So the first step here is to capture my brain data. Now, the plan is to do that by hacking a simple kid's toy called a MindFlex. The MindFlex contains a real, legit EEG chip made by a company called NeuroSky, and from what I've read, it actually exposes raw brainwave data. Now, a few of the folks over at Frontier Nerds came up with a way to hack the MindFlex with an Arduino and provide meaningful, human-readable data. So the plan is to take that data, serialize it, and send it to a cloud via an MQTT broker. Next, I'll create and deploy an application in the cloud that consumes the MQTT topic and persists it to a database in the cloud. For my video game stats, I'll grab those via HTTP calls to the unofficial Call of Duty API, and also persist them to the database. That way, I'll be able to combine my brain data and my stats to analyze the relationship. Let's pause for a second to talk about messaging. Now earlier I mentioned MQTT, which is a pub-sub messaging protocol that was created way back in 1999. The engineers who created it wanted it to be lightweight and use very little bandwidth, since the purpose of it was to monitor remote oil pipelines which were connected via satellite. And that kind of connection was not cheap back then. Now MQTT is just one protocol. There are others, but we'll talk about those in another video. As I mentioned, it uses the pub-sub pattern, which looks like this. A producer is a client that has a message, any message, that it publishes to an MQTT broker on a topic. Now, if there are no subscribers when the message is published, the broker simply gets rid of the incoming message. That is, unless the publisher says the message should be kept around. Now, if that happens, the broker keeps only the last message flagged to be retained. When a consumer or subscriber connects to the given topic, they'll immediately receive the last retained message and all incoming messages going forward until the consumer disconnects. Did you notice when I mentioned the broker just now, I said topic and not queue? That's right. Despite what you might think, MQTT does not use message queues. Instead, MQTT uses a broker which sits in the middle and essentially acts as a message router, shuffling messages between clients based on a topic, which is just a way to identify a group of messages. And that's a good spot to wrap this video up for now. In the next video, we'll actually open up the Mindflex and see if we can hack it and upload my brain data to the cloud. As always, thanks for watching.